Okay, so let's start with functional programming. Functional programming, see, there are a couple of things about functional programming. Okay, let me show you actually what functional programming is. Okay? So actually these are the features of functional programming. Okay, so when you're actually learning functional programming, it's purely based on the theory of lambda calculus, and the first property is immutability. So we have already seen immutability. So any functional programming will have this 7 properties. So firstly, immutability is there, which we already saw how we achieve immutability through the val keyword. Then it supports something called higher order functions. Okay, so higher order functions which we are going to learn today. So it's going to have higher order functions, and then it supports lazy loading. And lazy loading, we have already seen lazy loading. We have already seen immutability. We are going to learn about higher order functions today. Okay, so that's about the 3 things. But there are 4 more things, which basically makes functional programming what they are. There's something called pattern matching, currying. This is not the Indian or the Thai curry. This is a mathematics concept called function currying. And then you have something called partial applications, and then something called monads. So all this 7 properties actually goes into make. Okay, so let's learn higher order functions and functional programming. Okay, so let's look at what functional programming is all about. Okay, I told you about, so far we saw the object-oriented aspects. Now we are going to see the functional aspects of it. Okay, so firstly, we saw that functional programming mainly based on 2 ideas. The first thing is that functions are first-class citizens. So what do you mean by functions are first-class citizens? Functions are first-class citizens because it means that you can treat the function just as any other variable. Okay, so let's prove it. Okay, so here I'm in the Scala prompt. So here let me write the area, our old area function, length into here. Let's keep it simple. So here I've defined a function. Now I can call area rect like this. Okay, so it prints 90. Now what I can do is I can define a function f, a variable f, and I can assign the function to any variable. So basically this function area rect just behaves like a variable. So I can assign this function to another variable, and then I can call f just like another function. So it will print 90. Okay, and if you print the signature of f, it basically complies to the signature of rect. So here we have proved that that a function basically just acts, it's a first-class citizen because it just acts as any other variable. You can assign it to variables, and you must have noticed this underscore which I have put after this area rect. So this is a Scala syntax. See, the thing is that if you just put area rect, okay, it will try to call the function. Okay, so the compiler is going to, the runtime is going to actually call the function. So that's why you see that it's trying to call the area rect. So if here we don't want to call it, okay, we just want to assign the reference of area rect to f. So that's why we give an underscore. So an underscore here in Scala basically means that after a function name, it means that I'm assigning the reference to it. I'm not calling the function. So the reference of area rect, the address of area rect is assigned to f, and then I can call f like any other function. Okay, so it's not a lazy call, Ganesh. It's not a lazy call. It's basically just an assignment. Okay, that's how you assign functions. So if we have proved that it can be just treated like a variable, and it can be assigned to another variable. Now we are going to prove that it can be passed around just like any other variables, and it can be also returned from functions as variables. Okay, so these are basically first-class citizens. And now let's see what higher order functions are. Okay, so just remember this particular principle of higher order functions. So basically higher order functions are applications of first-class citizenship. They are any function, okay, which does at least any of the 2. So it takes any function as a parameter and or returns a function. So if any function takes another function as a parameter or returns a function as a value, as a return value, then it becomes a higher order function. Okay, so just remember that your functions are first-class citizens, and by first-class citizens I mean that they can be treated as any other variable, and higher order functions are functions which does at least one of the 2. That means takes a function as a parameter or returns the function. Okay, clear all of you what higher order functions are, what first-class citizenship is? So here I showed you what first-class citizenship is. Now I'm going to show you how we can how we can pass functions as parameters. Any questions so far? Okay, so let's define a method called add. Okay, so which takes integer a and integer b, and it returns the addition of a plus b. So this is the function I've written. Okay, so I defined a function add, and so which takes 2 parameters. And so this is just for examples, and I can pass 8 and 9 and it will give me 17. So similarly I can write another function called multiplication, which basically takes a and b and gives us the product. Okay, so 8 9s it will be 72. So these are the 2 functions we have defined. Now let me write a generic function. Okay, so let's write a generic function f. What it's going to do, it's going to basically take, so I write a generic function or a generic operation which basically takes a function. Okay, first tell me, are you clear with what I'm doing so far, this area rect and these things? Do you have any doubts? If you have doubts, you can quickly ask me before I get into anything complex. Okay, good. So now that you've understood, okay, fair enough. So now what I do is, I define something called a generic operation, where I define a function, which basically will have 2 integers as parameters and will return an integer. I give an operand 1 as integer and operand 2 as integer. Okay, and this basically returns an integer. So did you understand this? Let's go through the syntax which I wrote. So here what I'm doing is I'm defining a function called operation, whose first parameter is basically a function. Okay, its first parameter is a function, and this function signature is that it takes 2 parameters and basically returns an integer. So it basically takes 2 integers as parameters and returns an integer. So that is a function I've defined here. F, it can be anything, you can write A, B, C, anything here. So since it's a function, I wrote F here. So the signature, and then you write a colon, and then you say the signature should be of type this. That means it takes 2 integer parameters and returns an integer. Okay, and then what I do is, I take 2 operands. So I take the first operand as integer and second operand as an integer, and this function returns an integer. And in the body, what I do is this function, I call this function f, whatever I'm passing here, as with the parameters op1 and op2. Okay, so that's the function I've defined. So it's a generic operation function where it takes another function of this signature and 2 operands. Okay, now what I can do is, I can call this operation with add. Okay, and I can call 8 and 9. So basically what I want is, I want this operation function, and I'm passing the add function which I defined here. I'm passing the name of the function add, and I'm passing the parameters which I want to pass to add. And if I call this internally, it's actually going to translate the call to add with these 2 parameters. Similarly, I can call multiplication, so I can give the name mul which I defined here, and if I call this, so it will print 72. So that's how basically we are trying to pass a function as a parameter, and that's an application of higher order functions. Did you all understand this? Any doubts you have? Just maybe look at the syntax and try to understand what I've done here. Okay, Rao is asking me a couple of questions here. Ganesh is asking me, here you call directly add function. Yes, you're right. So what I'm doing here, Ganesh and Praveen, is that I declared a generic operation. So, and what I can do is, so here the generic operation, what I'm doing here is that I write the function declaration. Okay, and this basically has this particular signature. Okay, so that means that this particular, I have to pass any function which takes 2 integers as parameters and returns an integer. So as long as I pass any function which complies to this signature, this operation is going to work. And then I take the 2 operands, which I'm going to pass it to this function f. So in the body, basically, I just call the f with the 2 operands. So it's generic kind of binary operations where you can handle multiplication, addition, anything. Clear, Praveen? Okay, Shailaja is asking me what happens if add and multiply were returning float and also defining returning float. See, then you have to also define, redefine add and multiply to redefine float. So the best way is actually, if you can write a generic type, so instead of hard coding the variable, you can write t here, and I'll get to that a little later, Shailaja. First, let's understand this basic thing. Okay, so I'll come to that a little later, how we can convert that to a generic type. Okay, Vimla is asking me, can you pass any function implementation to f as long as they follow the f signature, right? Absolutely, Vimla. So you can pass any function, which basically takes this signature form. So that is also possible. Okay, the thing is that, Praveen, I'm just trying to explain to you the concept, try to understand the concept first, because then I'll come to complex examples a little later. It is true that, I can directly call the add and multiply. What is the big deal in calling through an operation? Many of you are wondering that I can directly call add and directly call multiply. So what is the big deal in actually calling it through operation? Well, this example may be silly, but what I'm trying to show you is actually how to do this. once you've understood how to do this, then we can actually go to more practical examples which can keep your head scratching. So first try to understand, okay, what the stuff is, and then I'll actually give you a lot of practical examples, but try to understand exactly how in principle, how it is working. Okay, my friends from Philippines, are you all clear with this? Rafaela, Kevin, Erwin, Nona, Rina, yes, okay, good. Okay, good. So, I'm very happy to see I have a very bright batch, because all of you are understanding things pretty fast. So it's good for me because then I can give you more complex examples. And when I go to Spark, I have actually a lot of illustrious plans for you, in Spark. Instead of using this VM, I actually want to show it to you in a cluster. So let me see what I can do. I can actually show you some stuff in cluster and show you how stuff works. Okay, so now the thing is, you must have noticed one thing that, this add, if I have to define an add function, I have to define a multiply function. It can actually become very boring, to actually define this one-line functions. And then your source code, will be littered with one-line functions. So there's a concept called anonymous functions, okay? Anonymous functions basically means that a function without a name. So what you can do is, you can actually call operation and define the function then and there, okay? So what I can do is when I call the operation, okay, I can then and there, define the function. So I can say a and b, and I can say that, it's equal to a plus b, and then I can pass, a and b any value. Or similarly, I can define an operation like a into b, okay. It will be multiplied, and similarly I can do a divided by b. So that's also one, okay. It does a, modulus arithmetic here. So the thing is here, these are called anonymous functions. That means, I didn't want to define the function outside because if you look at the multiplication implementation, it's just a one-line function. So I don't want to litter my source code with, just one-line functions everywhere. What I did was, I just wrote anonymously one function. So this function here, it's a definition itself. It's very similar to lambda expressions in Python. People who know Python will know this as lambda expressions. So it's just like that, okay? So I define the two variables here, a, b, and then I say a plus b. Okay, it can be any variable name. It's not a, b. You can give x, y also. You can name it after your your pet dog or pet cat. It's no big deal. Any valid name will do. Okay, so it can be x plus y. So basically, what we're doing is we're defining the function right away, then and there. Okay, so that's basically these are called anonymous functions. Clear all of you with this particular syntax? So you provide the parameters here. You don't have to provide the data type. Okay, so some of you may be wondering that, where is the data type? You don't have to provide the data type because the data type is automatically inferred from the parameters you're passing. But in case you want to provide the data type, you're free to do it. Okay, nobody basically stops you. Okay, Ganesh is asking me, can we call anonymous functions in multiple places or is it a single implementation? No, you can call it in multiple places, Ganesh, anonymous functions, wherever, you are. Anonymous function, the application is that, when you pass a function as a parameter to another function, and if the function is very small, you can actually write an anonymous function. And let me show you some examples now, in how we can do anonymous functions. So firstly, whatever that generic operation I did, if you want to actually make it very generic for any data type, so actually you can define it like this. So you can write a generic operation, you can write it like this, a generic operation. Let me copy and paste it so that all of you are clear. So what you can do is, you can write the function generic ops, okay? And you can say t. You can say that t should be a subclass of any, so that you don't pass any strings or nonsensical values. So it should be a subtype of any, which basically is given by this sign. That means it should be a subclass of any. And then you say f is of this signature and the operands are of this. So I just replaced the t with the float or the integer. Sorry, I just replaced the integers with t. And the only extra thing I did was after the function name in the square brackets, I wrote this. So now you can actually pass any stuff here. So if you want to call this, you can jolly well, call it like this. So if you want to call it for float, so you can say generic ops, you can write float here, and then you can say xy equals x into y, and then you pass 2.5f and 3. So this prints 0.75. Okay, similarly you can try it for float. So we tried it for float, now we can try it for integers. So you can just define the integer here. Okay, Vimla is asking, can the anonymous function have more than one line of code in the body? That's a very interesting question, Vimla is asking. Vimla is asking that, can I have more than one line of code in, in my anonymous function. The convention is, just to keep it to 1 or 2 lines. Okay, so if you have 2-3 lines of code, it's okay to have an anonymous function. But if you're writing some 10-20 lines of code or more than that, then obviously don't write it as an anonymous function, because then your code will become extremely unreadable. So if it's between 2-3 lines, it's absolutely fine to write anonymous functions. Okay, so Rafaela is asking me that do they all have the same type, or can I set op1 to different and op2 to different? Okay, Rafaela. Rafaela is asking me that can I make different types? So can I have t of something and t1 of something? Absolutely, you can do that. Okay, so you can make multiple types also. You can make this t, you can make this of type u, but the thing is that it should be addable. Like the sense in the sense that when you're adding a float to an int, you have to cast an int to a float. Okay, so internally that casting you have to support that. Or when you're adding an integer to a double, you have to first upcast the integer to a double and then add it. So it becomes a little bit complicated in terms of the code, but you can do that. Okay, so but it's better to add same types, then actually your code looks much neater. Otherwise, you will end up having t subclass of any, and then you write another type u subclass of any, and then you write f, t, and u returning t, and all these things you have to do. Yes, you're right. Ganesh is telling me that t a subclass of any, it's redundant. Obviously, it's redundant. I just wanted to show you that this particular operator, in case you want to subclass, this becomes very useful, because any class in Scala, is derived from any. But say, for example, you are trying to do a generic operation on a bunch of customers, and you want this customer, or maybe a set of bank accounts, and you want this t to be only subclasses of accounts. So then you can actually write something like this. Then it becomes, say, if you want t to be only subclass of accounts, so that people don't pass cat, dog, rats here. So you can do something like this. So only subclasses of accounts will be taken. Okay, so this kind of thing. Got it, Ganesh? Okay, good. Okay, so that's about generic operations. I'm going to show you some more examples on functions. So basically, just to go back and review, and this source code is there in my GitHub, so you can download it and have a look. There's another example I can give you. When you typically want to do transformations of, okay, no, I'll do that when I'm doing map and reduce. It will be easier to understand. Okay, so that's about how you do anonymous functions. So it's clear that, okay, Praveen is asking me, does it have any name calling function function definition? Sorry, Praveen, I did not understand your question. Maybe if you can rephrase. Okay, so let's quickly review. We have done inheritance, so that's basically done today. We did traits, that's finished. Functional programming concepts. I explained to you what first-class citizens are. What higher-order functions are. I gave you higher-order functions examples. I explained to you, anonymous functions and their uses. So you know when to use anonymous functions and what are their uses. Okay, sorry. So now what we're going to do is we're going to look into some more examples of application of higher order functions and anonymous functions. Okay, so we're going to look into four important functions: map, reduce, filter, and flat map. Okay, so what are they? So let's take a list, L, and let's take a number from 1 to 100, or maybe let's keep it simple, 1 to 20, and I convert to list. Okay, so now I have this numbers 1 to 20 as a list. Now the first function which I'm going to teach you is something called a map. Okay, so map, what it does is it basically applies. So the map function basically as an argument takes another function. Okay, and this function basically what it does is it does a transformation on each and every element of the list. So say for example I pass a function here, say for example n, and I say that n into 2. So here what happens is basically it means that this is a function definition n into 2. So that means every element, okay, every element of the list will be multiplied by 2. So that means every element will be passed through this function n into 2. So n will become 1, 1 into 2, then again n will become 2, 2 into 2, then n will become 3, n in 3 into 2, like that. Okay, so this particular function definition will be applied to each and every element. Clear, all of you, what this is? And if I run this, you will see that all the elements have been multiplied by 2. Is this clear to all of you? And there's a very interesting question which Vimla asked us, that is this map anything to do with map, the class map. Okay, we learned that, yesterday we learned a class map, okay, which is nothing but a hash table. So it's a hash table, okay, of key value pairs. Now this map function has nothing to do with the map class. Okay, just remember this, please. So it has nothing to do with this. No, Srinivasa, you cannot do that. It doesn't make sense. Okay, so what you're saying, Srinivasa, that's a wrong syntax. You cannot do this. Okay, so yes, you're right, Rao. So you can use this, to provide transformations to the map. So if you want to multiply this map, each and every element by 2, you can do this. Okay, so similarly, if you want to say, for example, you have a string, like test. So you can say str.map, and you can say each character, character dot lower. Sorry, what was the function? I think it was toLower, or I forgot the name of the function. Yeah, toLower. So what it does is, I have a function called test. A string called test, all in caps. So now what I do is, I want to convert this whole test to smaller case. So what I can do is, I can call each character, I can pass each character. I told you that string is like an iterator. So the map can be applied to any iterators, which is where every element is iterable. So here what happens is each character in the string is passed, is called with the function toLower, and then each character is reduced to a lowercase. Clear? So that's applications of map. Now the thing is, Scala, one reason why Scala becomes a little bit difficult to master is because, Scala has a variety of, syntax. So this, this thing which I wrote here, this lmap, this can also be written like this, okay? So it can also be written like this. This is called a wildcard, okay, in Scala, which basically means that, this underscore, it's like a wildcard. So that means every element of the list will be substituted here and will be multiplied by 2. So this is also a function definition in the wildcard form. Okay, so you give an underscore here, which means that every element of the iterator of the list is going to be substituted here and multiplied by 2. Okay, so you can use either this syntax or this syntax. Both are fine, whichever is comfortable. And both are functions, okay? So don't think that this is something else. This and this function is exactly the same. So the function definition here and the function definition, what I have written, is exactly the same. Here, instead of n, this function here like this, you just write an underscore. Clear? So that's a map function. So map is basically, if you want to transform an element, so let's write it down. So map function, nothing to do with the map class. Okay, it is used for transforming individual elements in an iterable collection. Clear? All of you, what a map is? I gave you 2 examples, one with a number and another with a string. Okay, so now we are going to learn the filter function. So filter is again, it's just to skim out whatever you want. Okay, and the filter function basically takes a Boolean predicate. So what happens here, so let's understand this with an example. So here, I have this original list. And what if I want only the odd numbers from the list? Okay, I only want the odd numbers from the list. So what I'll do is, I'll write a filter where I will say, I'll define a function where n, modulo 2 not equals to 0. So I've defined a function here where basically it's a Boolean predicate. It takes that n modulo 2 not equal to 0. So then it basically gives me all the odd numbers. Okay, and you can write it like this also as a wildcard form. Both are absolutely valid. So this will also give me the same thing. So filtration, remember, filter function you always use when you want to filter out something from the list. Yes, you're right, Ganesh. It's only used for collections, for traversable collections. And the expression should always have a Boolean. The return should be Boolean. Yes, Rao, you're right. Whatever you pass in the filter function, the return type should be Boolean. So that means the function here, obviously the return type is Boolean, right? So say, for example, if you write whether 2 equals to 3, this is a Boolean expression and the return is false. So similarly, whatever function you define here, it should be a Boolean, the return should be Boolean. So that means it should evaluate to a Boolean value. I'll come to that, Arvind. Arvind, I'll come to your questions, okay? So that's, the filter. Now let me go to reduce function, okay? So the reduce function, what reduce function does is, the reduce basically, accumulates the value of the collection. So it's like finding the sum. Okay, so you have this list here, you have this list. So if you do L.reduce and you write it like this, so this is the accumulator and this is the element, and you write it like accumulator plus element. So this basically gives the sum of the integers from 1 to 20. So that's exactly 210. Okay. So here accumulator is basically the counter variable. So it's 1 plus 2, 3, 3 is stored here, then 3 plus 3, 6, 6 is stored in ACC, then 6 plus 4, 10, 10 is stored in ACC, like that. Okay, so it keeps going on. Clear, all of you? So that's the reduce function, and the reduce can be also written using the wildcard syntax, which I have written before. You must be aware. So you can write it like this also. Absolutely fine. Okay. Okay. Here Rao is asking me that how ACC and N get the default values. What happens is if you look at the source code of reduce function, Rao, you will see that when you're doing addition, basically ACC is initialized to 1 because 1 is the identity. Sorry, is initialized to 0 because 0 is the identity for addition. And then it basically goes through each and every element of the collection and keeps accumulating that in ACC. Okay. And similarly, when you're multiplying, ACC is initialized to 1 because the identity in multiplication is 1, and it keeps on accumulating the multiplication values. Okay. So that's how it gets the. It's basically based on the operation. It gets the initial value. Okay, so if you look at the source code, you will see that the ACC is usually initialized to the first element of the collection, and that's how it keeps on doing the operation. Okay, so I don't want to open the source code, it's a little bit complicated, but in case you're interested, you can see that the ACC will be initialized to the first element, and then the counter will start. Okay. Ganesh is asking me, will that be used for Hadoop MapReduce functions? No, this has nothing to do with Hadoop MapReduce, please. It's just that they share the names. Okay, good. So these are the 3 functions we learned. Now let's see one requirement. If I give you the requirement that we have this list L. Okay, what I want from you is that skim out or filter out the odd numbers. Okay, then square them and find the sum. So how am I going to do it? So I'm saying that filter out only the odd numbers, then whatever you filtered out the odd numbers, square them and then find the sum. So how will you do this? So you will say L.filter, and then you're going to say filter out only the odd numbers. So what I'm going to do is n modulo 2 not equals to 0. Okay. So I do that. So I filter out all the odd numbers. Then I'm going to square them. So I pass it through a mapping function n to the power 2. And then what I do is, then I'm going to find the sum. So I reduce them, and I reduce it like this. Okay. Oh, sorry. This is a Python operator, so I have to use power function. So you can use the power function n2, and this will actually give you the answer. Just a minute. Now let's keep it simple. Hang on. Can you all see my screen? Okay, so this is what I'm doing. So I'm going to filter out all the odd numbers, then I'm squaring the numbers, and then what I'm doing is I'm finding the sum. So if you do this, this is the answer which you get. And you see this is called chaining, this is called function chaining. And you see that, how nicely I can get the, stuff. Clear? You can also use a wildcard, you can use the wildcard syntax to do this as well. So it's based on your convenience, how convenient you are in doing this. Oh, sorry. Okay, Rav is asking me in projects, do we use the wildcard syntax or no? It basically depends on your preference purely, and check the organization where you're working. What is the syntax they follow? Because in some companies, they strictly mandate this kind of a syntax, whereas in some other companies they are okay with wildcard. So just check what is the coding convention there. Both are equally okay. So and I've seen most of the places wildcard is used. There is no problem at all, but you have to check, with your project what they're comfortable with. Okay. And no, I got the above. Okay, Venkat is asking me why did I get the above error? Because obviously, I'm multiplying a wildcard with itself doesn't make sense. So there, I can't use a wildcard. I have to use a proper function definition. Okay, so because the compiler gets confused that what are these two wildcards here. Okay, but this is not the problem with the reduce function, because in the reduce, it knows very well. It is just folding the collection, but here, in the map, a confusion of it's the way the map is implemented. Clear, Venkat? Okay, so that's about the map reduce and the filter. Yeah, you're right, Venkat. Reduce has the functionality to understand, which map doesn't have. So now let's do some more fun with things. Have a nice day. Okay, so So this is the string I have. Let's do a word count, okay, of this. So let's do a word count. Shall we do a word count of this? Okay, so let's find out, to do a word count for this particular. So here we have a string, and I would like to do a word count for, just count the number of words this particular string has. So would you like to do this? Do you want me to show it to you how this is done? Okay, one more thing I wanted to show you is the flat map function. Okay, this is another very important concept, flat map function. So let me show you how flat map is done. Okay, so say for example, here I have an array of strings. Okay, are you all following me? Here, can you just look at the screen what I'm doing? I'm explaining to you the flat map function. It's a very important function which we are going to use in Scala, in Spark. So that time, I don't want to repeat myself. Please pay attention to what I'm doing here. Here we have this array. Okay, it's an array of strings. So that means, there are 3 sentences here. Hi there, how are you? Are you still there? So it's an array of strings I have, and these are words. So these are, 3 array of strings. It's an array of, 3 strings. Now, if I call words, if I want to get individual words out of this, so what should I do? I should call the map function, and what I do here is I basically split it based on spaces. Okay, so what I do here is I take the individual sentences and I split it up based on the space. Okay, so then I'm going to basically get the individual words here. Okay, so now you have the individual words, because previously they were sentences and now they are all words. Did you follow this line? What I did here, I took the map and split it. Can I have a yes, no, maybe, whatever? Got it? Now here you will see a problem. The problem is that you have an array of words. Okay, so which is not desirable. You have an array of words, which is what you don't want. Okay, you want basically an array of only the words. So it has got an array. So it's something like this. And if you want to visualize, it is something like this. You have an array. Okay, and each cell is again an array. Okay, it's again an array of words. So the first one, it's hi there, and again the second cell, it's an array of 3 words. How are you? Like that it goes on. Okay, I don't want this. So this is what I've got, but I don't want this. I basically want a single array. Okay, I want one array with all the words. Okay, so that means hi there, how are you still there? So all will come, in one array itself, rather than as an array of arrays. So how do I do this? The way to do it is use the flat map function. Okay, so it basically maps and then flattens. So the way to remember it is it basically first runs the map function and then it flattens the list. So now basically you get hi there, how are you? Okay, so this is basically how you have converted into one block of array. Are you all with me? Did you understand this line? Okay, so now okay, some questions here. Here Rao is asking me that okay, how do we use this in real time? Example. Yeah, first you tell me, Rao, whether you have understood this or not. That's more important before I get into real time or rather real life examples. Have you understood this? Okay, Shailaja is saying that we really don't need flat map for our example above, where there is only one array that we are getting by splitting the string. Okay, Venkat is also asking what is the real use. Okay, Ganesh is saying we are getting music. I don't know what it means. Is it a metaphor, Ganesh? Because I don't hear music anyway. Okay, Reena is asking me, is the space a delimiter? Yes, the space is the delimiter. Okay, Vimla is asking, the map function, does it always return some type of collection? Yes, you're right, Vimla. The map always returns a collection. It applies the function to each individual element and returns a new function. Right. Okay, concepts, you got it. Now, okay, fine. Now I'll just answer your Ganesh's and Venkat's question about real life applications. The thing is that, say for example, let's quickly get this. So say for example, you are reading, a file, okay, and you have read a file, and now what you want to do is, you want to, do some analytics on that, okay. So when we do Spark, I'm going to use this flat map a lot. So don't worry about real life example. You'll get fed up by seeing examples. But just to, quench your thirst, I'm just giving you the stuff here. Okay, Ganesh is saying that instead of array, can we move to list? Okay, it looks like he's allergic to arrays. Okay, Ganesh, so we'll move to list. Okay, so we have a list here. Okay, and now what we do is, I'll give you one practical application. So we have a list now. I can have words, and then I can run a flat map. And on that, I can split based on the spaces. Okay, so now you have a list of all the words. Now what I can do is, No, there will be some network latency, okay, in seeing the screen. So I change it to a list, and now what happens is, after doing the flat map, I can convert this, words into tuples. Okay, so now what happens is, these are individual words which are tuples. Okay, so as you can see, these are all tuples. Now, if I want to, convert them to lowercase, I can actually run another map function just after splitting. So I can say, to lower. So sorry. Okay, I'll come to that a little later, but just this step, have you understood this particular part, what I'm doing here? Have you all understood this? Okay, so now what I do is, I just convert everything to, I run another map function where I convert everything to lower. Okay, so what happened? There is no method called to lower, or what is it? Oh, I'm sorry, to lowercase. Okay. So then what happens is, all these things are converted to lowercase, and now you'll end up with tuples. Okay, and then you can count up the number of words which are occurring, and you can do analytics on that. And I'm going to do that more when I'm doing Spark tomorrow. But just to give you an example, say for example you read a file, and say instead of sentences, if these were files, then I could have read all the whole file, and I could have converted this to a tuple, and then I could have accumulated all the similar words, all the words together, and I could have got the word count. And after I get the word count, I can actually do analytics on that. So I can do all kinds of, I can find out how many words have occurred, how many how many times is how occurring, how many times is still occurring, and all kind of real-time analytics I can do. Clear, Rao, clear, Venkat? You asked that question. Yes, Ganesh. Then I can do real life operations. Okay, Shailaja is asking that how to combine the words to count up. No, that I'll show it to you tomorrow. Okay, you have to hang on. So I'll do it tomorrow. Okay, Vimla is asking that how do we know when does the map function will return an array or list or tuple? See, the thing is that whatever you're passing, that will be returned only. Okay, so the thing is that the original input of the words is list, so the map will return a list. If it had been an array, it returns an array. So whatever you pass in, only that collection is passed out. It's returned back. Clear, Vimla? So it's basically kind of garbage in, garbage out with the transformation. And Shailaja, split is a function of strings. Okay, it has nothing to do with map or flat map, so you can apply it anywhere. The split, you can see that I'm applying it on a string so the string, this two lowercase, these are all string functions. Okay, so you can check the string class for all the functions there. So maybe you can just have a look at that, and if you have any questions, you can ask me. So do you have any questions for me? Is everything clear today? So Shailaja, I hope it is clear, right? So the split, these are related to strings. Okay, so because you can see that I'm applying it on a string, okay, underscore dot. So that means this underscore is actually a string. Let's quickly finish off the quiz here. Yep. So functions can't be passed as arguments to Scala. Is this true or false? Yes, it's false. You can pass functions, and you can pass functions as arguments in Scala. And what are these called when you can pass functions as arguments? What is the phrase for that? What are those functions called where it takes functions as parameters? Yes, very good, Shailaja. Very good. Very good, all of you. They are called higher order functions, okay? Yeah, they are called higher order functions.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!